Okay, so that's the real situation in the industry in which it involves so many processes. So you need to know the mass balance of each single process and the overall process mass balance. Okay, so that's something that we're going to test next week. And for today, we are going to discuss about tutorial 3. I really hope that even before we started this session, I really hope that you already go through the question and try to uh, answer by your own based on your understanding. It's okay to be wrong because at least you try. When you try, at least you kind of like exposed with the question. And when I try to explain, definitely you will have more experience in answering the question, and you definitely will have more question to ask to me. If this is the first time you ever look at the tutorial question, then you're just going to follow the explanation I gave, and it's not going to give you any kind of like understanding in depth. So that's why I really encourage you for the tutorial to be try. You try your best. I know there are a few students who did that, and I really hope that most of you will do the same. Try to do the tutorial first. Well, basically the same tutorial that you can also get from your senior actually. So try to understand how the solution of the tutorial first, and then later if you have more question related to not only this kind of the question in the tutorial, but maybe something related to others within the same topic, we can try to discuss. Yeah. So I think that's the more effective way of learning instead of just waiting for me to give the solution and the answer. Okay, so because this is university level, and it's no longer about knowing what to do, but knowing how to do it too. Yeah, yeah, you need to do some deep learning. Yeah, when I say deep learning, that's mean that when you try to understand any kind of question and the solution, instead of just understanding how the solution is made, you need to also try to think, if I change this, what happened? If I change this, what happened? So when I next time during the test or during the exam, if I kind of like change or twist the question a bit, you still will be able to answer it because you have fully understand about that particular how to solve it. So from different angle, yeah. So that's something that I really want you to do proactively. So it's going to give you more understanding about this topic, okay? Because this is based on calculation. This subject is all about calculation. So if you uh did not proactively do all these exercises, tutorial, and so on, you will definitely struggle to answer question in the test and in the final exam. Yeah. Okay, so we are going to let me share the screen. Okay, so we are going to do tutorial 3, and this is related to the process, variable, mass, and volumes, and also the chemical composition. So we're going to start with the first topic, which is the mass and volume. So the first question, okay. So the mass and volume is all about density. Okay, just a brief about what we have learned under the mass and volume. We have density, we have specific gravity, and the other one is what? No answer. Okay, specific volume. So only these three, and also the what? The formula is very simple. Yeah, density is equal to mass over volume. Eh? And the specific gravity is equals to the density of the specific substance divided by the density of water, if no other density had been referred to. Because this bottom one is not necessarily water. I can change it to other referred material, but if no referred material had been stated in the question. So you can just use the density of water, which is 1000 kg meter cube. Okay. And then we have the specific volume, which is just the inverse of the density. Just like that, this very three simple formula. Okay. And all the question just need to refer back to the formula in order for you to answer the question, regardless how I twisted the question. When you see another as I mentioned before, the type of question will be asked in the test and in the exam will definitely going to be different from what you have in the tutorial. Tutorial is just going to give you basic understanding on how this concept or this formula will be used. However, I will do some twisted here and there in order for you to see how far that you understand and how far you know how to use all this formula. Yeah. So as long as you grab the main idea, as long as you know what to do, so you shouldn't be panic. When you see any kind of question, you read first, just stay calm, and then write the formula and see how by using the formula you'll be able to answer the question. Yeah. Okay, so we start with the first question. The density of a certain solution is 8.8 pound per gallon at 80 degree Fahrenheit. Okay, so we have the density and we have the temperature here. How many cubic feet will be occupied by 10,010 pound of this solution at the same temperature? Okay. So the first thing that you need to do when you see this kind of question is to write down the formula. Okay, so for this one is density. We have the density. We have the volume, the cubic feet volume, and we have the mass. So this is definitely we use the uh, density equals to mass over volume formula. Okay, why temperature involved here? If you notice in the lecture video that I gave, I say that the density will be changed according to different temperature, right? So the density of water will be different if I were to heat the water at 100 degrees C as to compare is the water is the room temperature. So then the density will be changed according to different temperature. However, in this case, the question asks about the same temperature. So that means that we don't have to consider the temperature as something that should be taken into consideration in answering the question. Because otherwise, if the density is 80 degree, if I say that then what is the occupied by 10,010 pound at maybe 120 degree Fahrenheit, then you need to go and see to the steam table. There's a table many pages that have different density of different liquid, and you need to see at let's say 180 degree Fahrenheit what is the density. You need to refer to that table, and we are not going to do that because that's not covered by this course yet. So that's why for this one it's just a simple using the formula in order for you to answer the question. And of course, there will be some unit conversion involved because this is the basic thing. And that's why the table of the conversion table that I give you, that's something that you need to keep. And that's something you need to always refer to and familiarize yourself with in order for you to answer the question. Definitely, the type of question asked in the test and in the exam will involve unit conversion. Not directly the unit conversion. Please change from 100 degrees C to 100 to Fahrenheit, let's say. That's direct change. But the type of unit conversion that will be asked in the question in the test and in the exam will be something like this. You know, I ask the density in this unit, and I want the answer of other, maybe I want the volume or the mass in other unit. So along the way, you do the calculation to find the volume or the mass. You need to also do the unit conversions. Okay. Okay, so we start first with the first question. So the first question. So we have the formula already. Equals to mass over volume. So now the question asks about how many volume, and it give the mass. So we need to kind of like more change the formula so that the volume is equals to density over mass. Sorry, terbalik pula. Sorry. Okay, it should be mass over density. Okay, so let's just do it. Okay, what is the mass? We have 10,010. Okay. So we need to do this long line here, pound, and then we have the what? Okay, we change this first because we want the answer to be in feet. Eh? So feet cubic. So hold on for a second. So the volume is 8.8. Okay. And then we have to divide with 8.8 pound per gallon. Okay, so this is the unit of the density. So they want the unit to be in feet cubic, in the cubic feet. Okay, so we need to do some. Okay, we already have the mass, we already have the density, so it's just a matter of changing the unit. Okay, so 1 gallon is equals to 0.134 feet, cubic feet. Okay, so we can cancel pound, pound, gallon, gallon. So at the end, we're going to get feet. So the answer would be 152 feet cubic. Okay, so this is the final answer for it. Okay, it's involved the usage of the formula, and in the same time, we have to do some unit conversion here. Okay, so let's move to the second question, and this is about the specific gravity. Okay, so specific gravity, we can use this lah. Okay, so the specific gravity of acetic acid is 1.049. Yeah, so specific gravity doesn't have any unit. Yeah, because it's density divided by density, so all the unit has been cancelled out. So specific gravity is dimensionless. So what is the density in pound pound feet cubic? Okay, so now we need to refer to the formula of the specific gravity, and there's no reference material have been included here, so we assume that we are going to use the density of water instead. So let's just try to do it. So this is for question 2. Okay, specific gravity is equals to density of that substance divided by the density of the water. So if you want to get the density of that specific for that material, it's equals to specific gravity times the density of the water. Okay, so now the question asks to have the density in pound per feet. But for the density of the water, normally we just refer to 10,000 kg over centimeter cube. Okay, so we need to do some unit conversion. Okay, so what we are going to do, okay. So we have the specific density of 1049. So it doesn't have any unit, dimensionless, and we are going to multiply with the density of the water, which is 1000 kg over meter cube. And then we want to change this unit so that it's going to fit the unit that the question asks. So kg, we change 1 kg equals to 2.205 pound. And then we want to also change the meter cube here to be feet. Okay, 1 meter equals to 3.2808 feet, and these all are in the power of 3. So at the end, you are going to get the final answer of 65.5 pound mass over feet cubic. Okay, so this is the final answer. Okay, I think so far, very direct, straightforward. It's just the method of using the formula and also the unit conversion. Okay, so we move to the third question. Okay, so a liquid has a specific gravity of 0.9 at 25 degrees C. What is its density at 25 degrees C? Okay, so 25, 25. So we don't have to do anything related to the density. We just need to use the formula because the temperature is similar. But they ask the density in kilogram over meter cube. And also the question also asks in B the specific volume, also the same temperature in feet square, feet cubic over pound. Okay. And lastly, if the liquid is placed in 1.5 liter bottle that has a mass of 222 gram, how much will the full bottle weight? Okay. So yeah, this one you need to think a bit. You know, you have a bottle. Let's say I don't know how to. Okay, let's just answer the first and the second question first. Okay. So we have the specific gravity and they want us to answer, we want to get the density, okay? So let's, and so this is 3A, okay? So specific gravity is equals to density over density of water. So density will be equals to specific gravity, which is 0.90, doesn't have any unit, and then we multiply with the uh density of water, which is 10,000 kg meter cube. And then we need to do some conversion. Sorry, no conversion because it's already asked in kg per meter cube. So the answer will be 900. Okay, so this is for the part A. So for 3B, it's asked about the specific volume. So specific volume is 1 over the density. So we have the density already, which is 900 kg per meter cube. But the one that been asked here is to be able to convert it into feet square over pound. So same thing. So what we need to do, okay, this is one. This is our mm, density, which is 9 kg over meter cube. Okay, and then we need to do some conversion. Okay, we start with 1 meter first. 1 meter is equals to 3.2808 feet, power of 3, and then we want to convert the kg to pound. Okay, 1 pound is equals to 0.454 kg. So we can cancel this and this, um, meter and meter. So at the end, we are going to get the final answer of 0.0178. feet cubic over pound mass. Okay, so this is the answer for question 3B. Okay, for question 3C, we need to find the weight, the mass of this substance. Okay, we already have the density, the specific volume, we have the specific the specific gravity, and we can find the I mean the weight of it. But so is mass, sorry, density is equal to mass over volume, right? So mass is density divided by volume. Okay, in this case, it's asked that the volume of the bottle, if I try to draw the bottle here, I don't know. Consider this is a bottle lah, yeah. Sorry. Okay, it's not really looking very nice. Why? Okay. Okay, so this is the bottle. Okay. And if imagine that the bottle has been filled up with this liquid full, so what is the volume of this liquid? Is the volume of the bottle, which is 1.5 liter. Okay. And we already have the what? We already have the density of it. And but in the same time, the question asks about the total weight. That's mean that it should be including the liquid plus the mass of the bottle. Okay. So first we need to find the liquid mass, the mass of the liquid first. Okay. So here we have the density, which is 900 kg meter cube, and then the volume is 1.5 liter, which is we want to convert this liter to meter cube. So 1 meter cube is equals to 1000 liter. So at the end, we are going to get the mass of the liquid is 1.582 kg. Okay, but we need to also add with the mass of the bottle. Okay, so for the total weight, the liquid is already 1.582 kg plus the mass of the bottle is 232 grams. So we need to do the conversion here. 201 1000 gram equals to 1 kg. So at the end, you're going to get the total weight is, sorry, this is not the total weight of it. Oh, this is the final answer actually. So can someone calculate how much 900 times 1.5 divided by 1000? One point three five kg. Okay. 1.35 kg. So 1.35 kg plus 0.232. The final answer will be 1.582 kg. So this is the mass, the total weight of the bottle filled with the liquid. Okay, so this is for the question 3A, 3B, and 3C. Any questions so far? Do you understand how I calculate to get the total weight of the bottle, the filled bottle? Yeah, so we have to consider the weight, the mass of the liquid, as well as the mass of the bottle. Okay, so that we're going to get the total weight. So that's something that you need to also very carefully read the question. Okay, so it's not about just getting the mass of the liquid, but also normally all this info will be very beneficial for you to be used in order for you to do the solution, the calculation, and so on. Okay. Okay, so that's about the mass and volume. I think, yeah, it's very straightforward. I don't think it's very difficult, but considering that you have all these all this formula with you, maybe the tricky part that you need to do is just to do the unit conversion along the way for you to answer this type of question. Okay, so that's for mass and volume. If no question, we are going to move to the next part, which is the chemical composition. Okay, under the chemical composition, we learn a few things about the mole. Okay, and the what the mole fraction, molecular weight. Also, we learn how to calculate the molecular weight, and then we learn about the mass and mole fraction. We also learn about ppm, which is the concentration part per million, and so on. This is something that had been touched with a few examples given in the lecture video. Yeah. So we start by answering question 1 first. So this one, calculate what is the molecular weight of calcium carbonate, if I'm not mistaken. Calcium carbonate, CaCO3, and the atomic weight had been given. Ca is 40.08, C is 12, and for the oxygen, the O is 16. Okay. So again, just want to highlight that the atomic weight as well as the molecular weight, if you still remember in my lecture note, I say that the the unit is flexible. Eh? The values same, but units flexible. This can be in kg or in pound or in ton. It's up to you to decide based on how you should do the solution, because it's going to facilitate for you to do the calculation in order for you to calculate the mole and so on. But if no unit has been given, so we're just going to use the SI unit. And in this case, it's in gram lah, because this is very small, tiny things, right? Okay, so the first question, what is the molecular weight of this substance here? Okay, so this is very easy. I'm just going to answer it here. Okay, so the molecular weight of it is, we have Ca 40.08, plus we have C, which is 12.01, and then we have oxygen with uh three component of oxygen here, so we need to multiply. Okay, 16 multiplied by 3. So you're going to get the final answer of 100.9. Okay, and this is in the gram per gram mole. Okay, so this is very basic. I think also you already learned this in the chemistry subject at school. Okay, so how many gram mole are in 10 gram of calcium carbonate? I don't know. This is calcium carbonate or calcium? I think calcium carbonate CaCO2. CaCO3 maybe different name. Okay, so for CaCO2, if we have 10 gram, how many gram mole? Okay, so we are going to refer back to the calculation of mole. Yeah. So they're just going to answer it here because I think this is very straightforward. So we have mole is equals to mass over molecular weight. We already have the molecular weight. We already have the mass. So it's just a matter of finding the mole, in which the mole will be in gram mole. Okay. So for question B, I just going to answer it here. This is for B. 10 gram, okay, divided by the molecular weight, which is 110 gram over gram mole. So cancel this. At the end, we are going to get the answer of 0.0999 gram mole. This is for B. For C, how many pound mole were are in 20 pound? Okay. So similarly, we just use this formula. Okay, we have the weight, the mass already, which is in pound, and then we have the molecular weight, which is 100.9. And this time, should we put it in the gram mole, or can we change it to other type of unit? The first answer is, sorry. Sorry, I can't. Which one? This one. 100. Oh, okay. I think they 100.1. 101. Oh, okay. This one, eh? Let me check. 100.1. Okay. Are you sure? Oh, yeah lah, betul lah eh. Oh, betul. Okay, sorry. What happened? Okay. Sorry. 100. You. That's why lah, it's more convenient to. So this one you need to change lah, eh? It's more convenient if I use the whiteboard physically instead of using it. So 101. Yeah, betul. Yeah, right. Okay. So this also one. And this is also one. Okay. So for C, 20 pound, and then we have the molecular weight. As I said before, the molecular weight unit can the molecular weight unit can is flexible. We can change if we want it to be, because this is in pound already, so no need for us to put gram over gram mole. We can just change this to pound per pound mole. Okay, so the value is this still the same, but it's just changing the unit, so that is going to make our life convenient. Okay, so the final answer for this is 0.20 pound mole. Okay. Any question? Anyone who doesn't understand why suddenly I changed the molecular weight unit just like that? Eh? No need for you to do the unit conversion whatsoever. Eh? See, this is very special features for molecular weight, in which it's the unit can be changed according to your how to answer the question. Yeah. Okay. So for D, how many grams are in 2 pound mole of this substance CaCO3? Okay. So now we are talking about the pound mole, and we want to have the mass. Okay. Before this is mole. And now, yeah, so we just going to change this a bit. So mass is mole times molecular weight. Okay, sorry, I just going to answer it here. So for D, the the mole is 2 pound mole. And then we want to answer the molecular weight. Okay, the for this one, the molecular weight should be in gram or in pound. Which one that you think is more convenient? You want to change this to gram or you want to change this to pound? The best way is to just fix with pound. Pound over pound mole. And then you are going to cancel this, and you're just going to get the pound. And then you convert the pound into gram. 1 pound is equals to 454 grams. So at the end, you are going to get the final answer of 9880 gram. So because the answer, the question is in gram, so this is the final answer. So no need for you to change because it's asked you in gram, no need for you to change the molecular weight first in gram, but solve the question first, so that you can cancel out the unit, and then after that you do the conversion, the unit conversion. Okay, so the final answer is 90,880 gram. Okay, so far any question? No question. Okay, no question. It's okay. So we are going to move to the second question here. And this one is related to the mass fraction and the concentration. Okay, so the table lists value of ferrum, cuprum, and plumbum in food wrapping paper for two different brands. So we have brand A and brand B. Convert all the ppm values to mass fraction. Okay, so the mass fraction is mass over total mass. Yeah. So how to solve this? Okay. For this one, I think I just need to use this. Okay. So question 3. Okay. So you can either change all this ppm to, to convert it into mole or the fraction, or we just can do the shortcut by just assuming that this is the mass. So I'm going to do the shortcut. Okay. So let me just total ppm. Okay, so this is for brand A, this is brand B. For brand A, we just total up all the ppm. 1310 plus 2000 plus 2,750. So you're going to get 6,060 ppm. Okay. And for brand B, 350 plus 50 plus 5. So you're going to get the total PM 450 ppm. Okay. So for this one, instead of you to change the ppm into some other unit, why don't we just assume that this is the mass, the total mass? Because what we want is just a fraction. So it's easier for us to do that way. Okay, let's start with brand A first. Okay, just going to make like a table here. For to answer this kind of question, I think it's better if you can came out the answer in type of table.
Sir,
So yeah,
for brand B, 405 ppm.
405 eh. Oh yeah, 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 yeah. 405. Betul. Saja je tak ni biar awak semua alert kan. Okay, so We are going to start. Okay, just going to. Oh my God, this table is really. I don't want to do the table lah. Actually. Okay. So okay. This is for ferrum. This is for cuprum, and this is for plumbum. Okay. So we start first with the first brand, which is brand A. So the mass fraction will be 1310 divided by the total ppm, which is 6,660. So the fraction will be 0.216. And the same goes to the second one, 2000 divided by 6060. So you're going to get 0.330. And lastly, 2750 divided by 6060, you're going to get 0.450. Okay, so if you total up this mesh fraction, this mesh fraction, and this mesh fraction, the final answer for the total up will be 1. And for brand B, similarly, 350, and this time we just divide with the total ppm of brand B, which is 405. And the answer will be 0.864. Please do the calculation with me to double check whether I calculate it, whether I calculate correctly or not. 0.123, and lastly for this one, 5 divided by 405 is equals to 0.0123. Okay. So when we total up this, and this, the answer will be 1, 2. So these are the way to do the mass fraction. Okay. Sama tak? Okay tak? Any mistake? I think no. So normally just going to put it like in the table. Okay, like this. Okay, sorry. But I think you still can see the calculation clearly, right? So this is the way to answer question 3. Okay. So no more mistake, right? Betul kan? Everyone ni betul kan? Okay. So we are going to sorry. We are going to go for sorry, this is question 2, and now we are going to do question 3. Okay, for this one, this is to calculate the mass fraction, mole, and mole fraction. Okay, so this is something similar with the example that I have given in the lecture video. Okay, so there's a few steps that you need to do. A mixture of gases have the following composition by mass. Okay, so we have O2, CO, CO2, and N, and we have the percentage in the composition. So all of this is equals to 100. And these are the molecular weight of each gas. Eh? So calculate the mass fraction, mole fraction of each composition in the gas mixture. Okay. For this one, we need to have a basis lah, like a basis. Okay. So for instance, because it's in a mass and we already have the percentage like this, so we're just going to assume that the basis of the gas, the mixer gas, is 100 gram. So it's easier for us to convert. Let's say in 100 gram, we have 16 gram of O2. We have 4 gram of CO, 17 gram of CO2, and 63 gram of nitrogen. Because it's stated here that the composition by mass. So 100 gram is equal to this lah. So if you already have the basis, like 100 gram, you can also use the basis 1000 gram if you want. But I think the most convenient way is just 100 gram because this is just referring to the percentage here. Okay. So if you already have the basis, we can do all the calculation. We can have the mass, we can have the mass fraction, mole and mole fraction. So I'm going to answer it here. We start by, okay, so this is going to be the component. And then we have the mass and the mass fraction. Okay, we start this first. What are the components? We have O2, we have CO, we have CO2, and we have N2. So the bottom is just going to take. Okay, so by considering that we have the basis of 100. So what is the mass for 100 gram of, what is the mass of oxygen inside of that 100 gram gas? Because the oxygen represents 16%. So for 100, that means the oxygen weight is 16. The mass is 16 gram. So just going to straightforward use that. So this is going to be 16 gram. I just going to put the unit here, 16 gram. And then 4, 17, and 63. Okay, so the total mass is 100 gram. Okay, so the mass fraction, similarly lah, 16 divided 100 is equal to 0.16. 4 divided by 100 is equal to 0.04. 17 divided by 100 is equals to 0.17. And 63 divided by 100 is equals to 0.63. So when we sum up this mass fraction, it will equals to 1. Okay, so we already finished the mass fraction, mass and mass fraction. Now we want to do the calculation for the moles and the mole fraction, and we have been given with the molecular weight. Okay, for the oxygen is 32, and this is in gram per gram mole. So for oxygen is 32 because it's 16 times 2. And then for CO, we have 28. For CO2, we have 44. And for nitrogen, we have 28. So this is the molecular weight. Why we need to have the molecular weight? Because we have the moles equals to mass over molecular weight. So we want to know the moles we already have the mass, we already have the molecular weight now. So we can just get the moles. So moles, which is in the unit of gram mole. Okay, so consistent, yeah, gram over gram mole and gram mole. So this one 16 divided by 32 equals to 0.5. 28 divided, sorry, 4 divided by 28 equals to 0.143. 17 divided by 44 equals to 0.386. And lastly, 63 divided by 28. So we have 2.250. So for this one, the total moles of all is, we have to sum it up in order for us to calculate the mole fraction, is 3.279. Okay, so we already have the individual moles and we have the total moles, so we can calculate the mole fraction. The mole fraction. Okay, so the mole fraction, just individual mole 0.5 divided by 3279. So this is equals to 0.1 5. And then we have 0.143 divided by 3.279. This is equals to 0.044. And then we have 0.386 divided by 3.279. This one we have 0.120. And lastly, 2.250 divided by 3.279. This one we got 0.690. Okay, so at the end, these are the mole fraction of each gas in the gas mixture, which is the total mole fraction. If we sum it up, will lead to 1. So this is, I think this is the way to answer the question like this. You do step by step like this. Maybe you can just put it in the table. I'm so sorry. I don't think I will put it in. Will draw a line because it's going to mess up the this page. But if you draw and if you answer the question in the test or in the exam, please draw like a line so that it's clearer. Even for me to answer the to do the marking for the test and the exam is more convenient for me to have it in a table like this. Okay, so I'm going to just calculate. Okay, so the student managed to answer the mass. Okay, this is right. And then the mass fraction, okay, this is right. But please also show some of the calculation step, okay? And then the moles, how they calculate the moles, okay, this is how they do it, okay, good, right? So this is the total mole, and then I'm going to mark this. So step by step, it's convenient for me to do the marking if you to answer the question like this in this kind of format, okay? So any question for this question? Anyone who doesn't understand the way I answer this question? I think this is similar like what been shown in the video. The same step is just the matter. Maybe what you need to do is to think about this basis first in order for you to answer it. Okay, so this is something that you need to think beyond the example. Yeah. So yep, that's about it. We already cover the tutorial 3 related to the mass volumes and also the chemical compositions. Any question related to this tutorial? And I really hope that you will also do other exercises and other examples. Please refer to the textbook. Okay, because for the tutorial, I think this is just not enough. Okay. Just 3 questions per topic. I think it's not enough. There definitely be a lot of questions can be asked from this topic and the other topic that had been discussed earlier. So that's why the most important thing is for you to get the basic understanding on this topic. And if you already grab the main idea of the topic, you will be able to answer the question. Whatever question that related to this topic can be answered confidently. And again, this is a calculation subject. So there will be a lot of calculation involved. And I believe not all of you are really good in doing the calculation. Yeah, because have our own strength and weaknesses. Some of you might have the strength of memorizing, you know. You can memorize every single words in the book text. But when it comes to the calculation, some of you might have the advantage of just like when you see this, you can fully understand, you can do the calculation straight away without any mistake. Some of you might need to do a lot of exercises in order to polish your calculation skill. Some of you will do a lot of error mistake, some stupid mistake. Uh, like what I did before, 10, 100 01 lah, macam something like that. Very stupid mistake and will lead to some mistake with the subsequent calculation. So be careful with the way the step of the calculation. As an engineer, this is very important for you because if you do the calculation mistakenly do the calculation, it will cause, loss to the company, to the industry, and you don't want that to happen. Eh? So please be careful when you do the calculation step by step. Eh? Okay. Any question?
No, doctor.
Yep. No, oh no question. Okay, I thought you want to ask question. Okay. Um. Okay, because all of you try to communicate through chat. When I share the screen, I cannot see the chat. So that's why better for you next time during class like this, if you think that I have done some mistake, please just say lah. Just unmute and say it to me. Huh? Instead of just I know because your generation you prefer to have it, through chat, WhatsApp, instead of having the real conversation. But I think it's also depends to the situation lah. Like this one is more convenient for you to just speak up instead of chatting, because otherwise I will not going to notice the chat, because when I share the screen, the chat will not going to pop up. Okay. So, okay. So, if there's no question, that's the end of our class today. Thank you for joining this session. Um, Next week, we're going to have tutorial 4 related to the mass balance. I think I want to give quiz, but I'm not sure yet. But let's see. And then the following week, we're going to have our first test. Yeah. So please, again, I would like to remind everyone, please do the example and again do this tutorial. For those who haven't do the tutorial, please do it. And it's best for you to try to solve it by your own first, and then compare with the answer that have been given in this session, so that after that you're going to get more understanding. We learn from mistake. Everybody do that. Everybody does that. So that's the best way of doing it. And also, if you want to have, like, I don't know whether do you have in like a study group, or you studied your own by your own. I think you need to do some strategy too, because you are in your first year. I don't know, so some of you from diploma system, so maybe you are already aware about the campus life and so on. But I would encourage you to have like a small study group, not very big, because otherwise the purpose of having the study group will be defeated, because you're going to do a lot of chatting, makan-makan, those kind of thing. But if you have like a serious small group that you can do discussion, and then maybe yeah, this is what I did during my time as a student. We are going to, let's say, for the final exam lah, because the final exam already being covered so many topics already, and some of the topic we kind of like forgotten already. So every student, every members of the group, we kind of like focus on specific topic, and then we are going to teach our friends in the group, eh? Just to refresh back what the lecture has teach us in the class. And then I think that's one of the effective way, because when you learn something, in order for you to teach people, definitely you will learn it like like you really want to understand every single thing about it, because you afraid that people will ask you question and you don't know the answer. Similarly, like in my case too, when I, as a student, when I just, when lecturer teach in the class, we just, oh, okay, understand, but we don't have the commitment of teaching people what we already understood in the class. So that's why I kind of like take it for granted. uh, in comparison, like now, when I have to teach you, I definitely have to understand every single topic first. And not just understand, I need to think about what, from different angle, from different perspective about this, and what the potential question will be asked from the student. Then I will be more confident to teach you. So when I did that, the understanding, the way I understand every single topic will be different. It will be more detailed. I I can grab the main ideas of it, and when any question comes, I can confidently answer. So I think that's the best way of study lah. If no one want to listen to you, or no one want to that you have no one to teach, maybe you can teach yourself in front of the mirror. Belajar untuk mengajar. That's the concept lah. Belajar untuk mengajar. When you do that, it will go straight into your heart, genuinely, and then you you want to and then uh you can just practice what you have learned and what you already understood. Okay. I don't know whether you understand the concept I just teach you, but this is one of the strategy that I follow during the time I was as a student. But in the same time, I also work closely with my senior. Do you have any like a session with your senior? Did any mentor mentee system? Hmm? Ada tak?
No, Doctor.
No. So during my time, every senior will be paired with junior. One senior with one junior. So every semester, when I started the semester, I will go to that senior. I will ask for notes from her. I will pay. I was paired with one kakak lah, one senior kakak sister. So every time I move to the next semester, the new semester, I will ask notes and every learning material from her. So and I was lucky because my senior was very, I have a very good record management. So all the notes that she has, she gave to me, and so I already have in advance every single notes for that semester. That's what I did. And if I maybe if I ask question to the senior related to the topic that I did not understand, the senior might be forget already. But the notes there, including all the answer and everything that we can use in order for us to solve any kind of question. So it's make me more prepared during the early of the semester, in comparison for those who are having no idea, just waiting for the lecturer to give you notes every single week. So you can also do the same proactive way by approaching your senior. You don't have to wait for prophet to initiate it. You already know your senior. Maybe you can just approach them. You are already in the course, right? So just approach them and ask, kakak, abang, can you give me your notes? Do you still keep your note? I don't know whether they keep or not, or maybe most of the time, maybe now we don't have the hard copy, we have the soft copy already. So it's good. Maybe you can use the soft copy and just save it in your computer. Just go through everything, all the thing, the tutorial thing, everything I already discussed. The same thing with your senior actually. You can ask Zhao. Okay, so the same thing. So maybe the one that need, but still lah. Don't just because the senior already got all the answer, the solution, you just follow and then you do nothing. You don't try to give effort to understand more. You have the answer already, all the tutorial question from the past, but you already do the shortcut there. But why don't you put the effort, the extra effort to get more question that is not in the tutorial? Eh? By going to the library, referring to the book, the textbooks, or just Google. Yeah, that's the strategy lah. Maybe that's a soft skill that you need to also learn. Maintain a good relationship with your senior lah. I think that's one of the tips that I can give you. That is what I did during my time. Even during the time I was as a senior, my junior, the one that had been paired with me, I also, because the senior had gave me the notes, so I also kind of like keep all the notes properly so that I can give to my junior. So my junior also get the benefit from me by getting all the notes in the early semester. Huh? Understand? Okay, so there's some tips during the afternoon session of Ramadan. So I think that's all for today class. I really wish you all the best and don't forget to submit this tutorial in the Putra Blast and also the exercise too. I can see there are few other students who haven't submit exercise and the tutorial that should be submitted by bukan next week, by tomorrow. So please do that, you know. And ni lah, I wish you all the best and selamat berbuka. Thank you. Bye-bye. Assalamualaikum.
Thank you very much,
Okay.
Doctor.
Salam.
Thank you, Doctor.
Salam.